components in an undirected graph. The problem statement says you have a graph of n nodes. You are given an integer n and an array edges where edges of I is equal to ai comma bi indicates that there is an edge between ai and bi in the graph. Return the number of connected components in the graph. We can make the edges as an adjacency list, which would make it easy to do a DFS search on the entire graph. Go through every single node, do DFS and mark visited nodes. We will be able to find one connected component. We will use union find algorithm. This algorithm was made for a problem like this, to count connected components as well as to be able to identify disjoint sets. The solution code gives an undirected graph with n nodes labeled 0 to n-1 and a list of edges where each edge connects two nodes and asks us to determine how many connected components the graph contains. It uses disjoint set union data structure to count connected components by initially assuming each of the n nodes is its own component, then gradually merging components as edges are processed. The PAR array tracks each node's parent, representing the component leader, while the size array keeps the size of each component to support union by size. The find function locates the root parent of a node and applies path compression, flattening the structure to make future lookups faster. The union function connects two nodes by attaching the smaller component under the larger one, returning 1 if a merge happened and 0 if the nodes were already connected. Starting with components as equal to n, each successful union reduces the component count by 1, and after processing all edges, the remaining value represents the total number of connected components in the graph. The patterns which is observed while solving this type of data structure is first is disjoint sets union find pattern, where the core idea is track which elements belong to the same group and efficiently merge groups. Second is amortized optimization thinking. This problem introduces a huge DSA mindset shift. Worst case is not equal to real world cost. Third is component counting via merges. Instead of discovering components after, we count while merging. Fourth is implicit graph representation. Fifth is union by rank size heuristic. This teaches structural optimization. Always attach smaller structures under larger ones. Sixth one is problem to pattern recognition. Seventh one is Leetcode system thinking, where the intuition which I used in this problem statement fits perfectly.